Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you like my videos and you find them helpful and interesting to your studies, also please don't forget to subscribe. Draw the influence line for the vertical deflections at point C. Deflect vertical deflection at point C of the simply supported beam shown below. EI is constant. So here's the beam. C is at the center of the beam. So the reactions would be when the load is at C would be zero point 0.5 at A, zero point 0.5 also at B. So by double integration method, so we section here. This is point D, the arbitrary point. So EI F DC double prime is equal to zero point 0.5 or 1/2 of x minus 1 times x minus 5. So AIF double prime of DC equals 0 0.5 of x minus 1 times x minus 5. EIF prime DC is 1/4 x squared over 4 minus 1/2 of quantity x minus 5 squared plus c sub 1. Then because the origin is a support, so there is no c sub 2 or c sub 2 is 0. Integrating further, EI FDC is equal to x cubed over 12 minus 1/6 quantity x minus 5 cubed plus c sub 1 of x. When x is 10, y is 0, FDC is 0. So 0 equals 10 cubed over 12 minus 1/6 of 5 cubed plus c sub 1 times 10. Solving for c sub 1 is equal to negative 6.25. Therefore, EIFDC is equal to 1 x cubed over 12 minus 1/6 x quantity x minus 5 cubed minus 6.25 of x. Or FCD, which is equal to FDC, is equal to 1 over EI quantity x cubed over 12 minus 1/6 of x minus 5 cubed minus 6.25x. So when x is 5, 5 cubed over 12 minus 6.25 times 5 will give us, so this is the influence line for vertical reaction at C. That's FCD equals FDC equals 1 over EI quantity x cubed over 12 minus 1/6 of quantity x minus 5 cubed minus 6.25x. And when x is 5, FDC is negative 125 over 6 EI. Then by conjugate beam method, so that's the influence line for deflection at C, vertical deflection at C in meter per kilonewton. So for conjugate beam method, this is the conjugate beam and the load would be 1/2 or 0.5 of 10, so 5 over EI first degree. Then for the load 1 times 5, so 5 over EI. So we select this as D at distance x from support A, and this is 1 over EI times x minus 5 because the unit load is 1 and this distance is x minus 5, x minus 5. While this is 1/2 times x or x over 2 EI. Then let's select the whole system first, call this theta A. So summation moment B equals 0, theta A times 10 plus 1/2 of 10 times 5 over EI times 10/3, then equals 1/2 of 5 times 5 over EI times 5/3 then minus 6.25 or plus negative 6.25 times 10. So solving for theta A is negative 6.25, or sorry, theta A times 10 plus 1 half of 10 times 5 over AI times 10 thirds equals 1 half of 5 times 5 times 5 over EI times 5 thirds. So theta A is negative 6.25 over EI. Having known theta A, so we consider this section. This is FDC, and we have theta D positive going down. Then let's consider AD or ACD. Summation moment about D equals 0. So we have FDC plus 1 half of quantity x minus 5 times x minus 5 over EI times x minus 5 over 3, the moment arm, then equals 1 half of x times x over 2 EI times x over 3 plus theta A times x, or plus negative 6.25 over EI times x. So notice that if we transpose this to the right, this equation is the same as this equation here. So FDC, which is equal to FCD, equals 1 over EI, quantity x cubed over 12 plus x minus 5 cubed over 6 minus 6.25x. So that's it. And we have the same vertical deflection at C, elastic influence line for vertical deflection at C.